Hello friends, to this second session on sets. In our last video session we had a discussion, an introductory discussion about sets. Therein we also discussed the sets and what are the various elements of a set and how do we denote the set and the elements that are there in the set. Apart from that, we also discussed the representation, how are the sets represented, and we saw that there were two forms in which you can represent the sets: the roster tabular form and the set builder form. Now, just to understand how much you have been able to grasp from the earlier discussion, let me give you a quick question. So this is the question: write the set A is equal to 1, 4, 9, 16, 25 in set builder form. Now you would see that this is the tabular form because here we have listed all the elements in the set 1, 4, 9, 16, 25, and dot 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 means that this particular set continues till infinity. So 1, 4, 9, 16, 25, and they are all squares of the natural numbers. So square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and so on. So you can now guess that the next number would be 36 and 49 and then 64, 81, 100 and so on. Now this particular representation is the tabular form, and now we have to convert it into the set builder form. And how do we do this? You would recall from our earlier discussion that we have to identify one property that is common to all the elements, and using that property we can represent the set in the set builder form. So what is the property? The property is that these numbers are all squares of the natural number. What are the natural numbers? Natural numbers start from 1 and they continue till infinity. So basically these are all squares of the natural number. For example, natural number, the first natural number is 1, the second one is 2, 3, 4, 5, so on, and these are all squares. Square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and so on. So how do we write this in the set builder form? We can write it in this particular fashion: a is equal to x such that x is the square of a natural number. And alternatively, you can also write a is equal to x such that x is equal to n square, where n belongs to capital N. Basically, capital N is the set that denotes all the natural numbers, and so we are saying that n, the small n, belongs to capital N, means the small n basically they are different natural numbers. So a is equal to x such that x is equal to n square. So for every single natural number you will have to find out the square. So a is equal to x such that x is equal to n square. So square of 1 would be 1, square of 2 would be 4, square of 3 would be 9, and so on. So this now becomes the set builder form. Okay. Now let us move forward. Let us discuss the different types of sets. There are finite sets and infinite sets, and you would be able to guess the difference between the two. What are finite sets and what are infinite sets? Finite sets would have finite number of elements, while in infinite sets you will have infinite number of elements. So that is the basic difference. It is self-explanatory. Let us have a look at one example. A is equal to x such that x, number of subjects in BBA second semester. So how many subjects are there? There are 6 subjects. So this is a finite number, and that is why this is a finite set. Or let's say number of boys in the BA third year. Again, this would be a finite number, and that is why these would be finite sets. Now let us talk about the infinite sets. As I've told you, infinite number of elements would be there. Example: a is equal to x such that x is equal to even number. So basically this is a set of all the even numbers: 2, 4, 6, 8, 10, 12, 14, stretching up to infinity, and that is why this is an infinite set. 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth, and that is why this is an infinite set. So these are the differences between the finite and infinite set. Very, very simple. Now an exercise for you. Find out which of these are finite sets and which ones are infinite sets. I'll do the first one for you. X such that X belongs to n. N here denotes the natural numbers 1 to infinity, 1, 2, 3, 4 to infinity. So X such that X belongs to natural number and X minus 1 into X minus 2 is equal to 0. You would recall from your classes in your secondary school that X minus 1 into X minus 2 is equal to 0 would mean that X is equal to 1. In the first step, what you will do, X minus 1 is equal to 0 and that is why X equal to 1. In the second step, X minus 2 is equal to 0 and that is why X equal to 2. So there are two values of X which satisfy this equation. One is 1 and the other one is 2. So basically you can have a look here at the solution. The given set will have only two elements, 1 and 2, and that is why it is a finite set. Is this fine? Now let's have a look at the third example. X such that X belongs to n and 2x minus 1 is equal to 0. So X is a number, X is a natural number, X belongs to n, which means X has to be 1, 2, 3, 4 and so on. And the other thing which has been mentioned is that 2x minus 1 is equal to 0. From here we'll deduce the value of X and we'll find that X is equal to 1 by 2. However, the first portion tells us that X has to be a natural number, which means X has to be 1, 2, 3, 4, 5, 6 and so on. While the second portion tells us that X is equal to 1 by 2. There is no such number which satisfies both these two conditions, and that is why this will be a null set or a void set. What is a null or a void set? We'll be discussing it later on also. Null or void set is which does not have any element. So as we assume that the only element in such kind of a set is phi. So which has been shown here, given set is equal to phi. There is just one element which is phi because there is no other value of X which satisfies the conditions, both the conditions which have been mentioned here. So the only element will be considered to be phi. This sign which you are seeing like this, O crossed with a vertical line, this is called phi. And basically there is just one element which is phi, and that is why it is a finite set. Is this okay? On the other hand, have a look at the fifth example. X such that X belongs to n, which means X is a natural number and X is odd, which means the value of X could be 1, 3, 5, 7, 9 and it could go on till infinity, and that is why this is going to be an infinite set. Is this okay? Now the task for you is to have a look at other questions also and try and understand the logic and try and solve them on your own. Now let us discuss the one more important type of sets, which is the empty null or void set. Just now you would remember in the third example I discussed this particular type of set which is a null or a void set, and I told you have a look here. Solution number third, given set is equal to, I told you this is called phi. Now given set is equal to phi. Phi is one element which is considered to be member of every set. So even if a set does not have any element, it would even then have at least one element, and that element would be phi. So we are going to discuss these kind of sets only here. Empty sets, null sets or void sets, they don't contain an element, and the exception is that there would be a phi. If they do not have any element, even then the only element which will be there will be considered a phi. See, these kind of sets are denoted by curly brackets without anything written between them, or phi. Example A is equal to X such that X is equal to student of BBA second semester and BBA fourth semester. Now please understand, this is the set builder form, and we can understand that X is a student who belongs to both BBA second semester and BBA fourth semester. You would understand that there can be no student who is studying both in the second and the fourth semester. It's just not possible, which means this particular set will not have any element. This is basically an empty null or void set. Is this fine? Now let us talk about the equal sets. What do we mean by equal sets? Sets with the same elements, and they are denoted by A is equal to B. So if two sets, let's say A and B, they have the same elements. The serial order is not important. We have discussed this in the earlier lecture also. The serial number is not important, but the element should be the same. So if two different sets have the same elements in whatever serial order, that is immaterial, then the two sets would be called equal sets, and they would be denoted by A is equal to B. Here A and B are two sets, and the sign of equality, the sign equal sign, shows the equality of the two sets. We'll take up one example to make you understand this thing better. So the first example is very simple. You can understand A is equal to 1, 2, 3, 4, B is equal to 3, 1, 4, 2. Though there is a difference of sequencing, the serial order is different, but still the elements are the same. There are 4 elements here, 4 in the other set also, and the elements which are there are also same. In A there is 1, 2, 3, 4. In B also we have 1, 2, 3, 4, but in a slightly different order. So these two sets are equal. Now again, you have a look at the second question and you try and solve this on your own. You can pause the video here so that you can have a detailed look at the question and try and solve it on your own, and you would be able to understand that the two sets, that is A and P, in this particular example, they would be equal sets. Okay. Now let's talk about sets, subsets and supersets. Now this is probably you must have heard of sets and subsets, but probably superset might be one term that might be new to you. So we are going to discuss them today. Sets, subsets and supersets. What do we mean by these three terms? Now please understand, if all the elements of a set A are also there in set B, so all the elements of set A are also part of set B, then in that case A would be called a subset of B, and this is the symbol that denotes the subset. So A here is a subset of B, and the symbol looks like C in the second line after the semicolon. A and then is a subset of B. This looks like C. So basically this is a symbol used to denote a subset. So A is a subset of B because all the elements of A are also there in set B. In this case we can also say that the B is the superset of A. So because A is the subset of B, so B has to be the superset of A. Is this fine? So let us take an example. The example here I have quoted again from the department. P is equal to a set that denotes the girls pursuing BBA from Pythagoras, and Q is equal to the students pursuing BBA from Pythagoras. Now, girls pursuing BBA from Pythagoras and students pursuing BBA from Pythagoras, you would be able to understand that students pursuing BBA from Pythagoras would include both boys and girls. So basically, all the girls would also be part of the students group, which means P, all the elements in P would also be there in Q, and that is why we are saying here that P is a subset of Q. But the reverse is not the case. The opposite is not always the case. There may be exceptions, but it may not always be the case. So here P is a subset of Q, but Q is not a subset of P because Q would also include boys who are pursuing BBA from Pythagoras, while P does not include boys, it only includes girls. So Q is not a subset of P. As I've already mentioned, there could be cases when two sets, let's say G and H. So G is a subset of H and the H is the subset of G. This kind of a situation is possible. So G is a subset of H and H is a subset of G. It is possible, and it would only mean that G and H are equal sets. I have not mentioned it here, plus please make a note of this on your own, that if G is a subset of H and another set H is a subset of G, which means both the sets are subsets of each other. In this case, we can say that the two sets are basically equal. So this can only be possible when G is equal to H. Then G will be a subset of H and H will be a subset of G. Another example we have taken up, P is equal to A and Q is equal to AB. Now you can easily understand that P is a subset of Q, but Q is not a subset of P. So these are some of the examples that you'll have to solve. and hopefully you'd be able to solve them on your own. I would only be discussing the first one, that is example 9. So there are 4 sets here. The first set is phi, which means it's a null set, void set. We have already discussed this. The second set is A is equal to 1, 3, which means it has only 2 elements. The third set B has 3 elements, and the fourth set has 5 elements. Now let's have a look at the question first. Whether phi is a subset of B, yes or no. That is what you have to mention. So if you put a sign which looks like this C, which looks very much similar to C, the English alphabet C, basically is denoting subset. So putting this in between will mean that phi is a subset of B. And if you cross this C, it would mean that phi is not a subset of B. Now please understand, we had already said that phi is considered to be an element of every set. Even if any set does not have even one element, there could be sets which don't have even one element, even they will have phi. So phi is a subset of every single element, every single set. Phi would be considered to be an element. I am repeating it again. Phi would be considered an element of every set, and that is why the solution is showing you that phi is a subset of B. Yes, phi is a subset of every set. Let's have a look at the second question. A has 2 elements 1 and 3 and B has 1, 5, 9. You would be able to spot that 1 is present in both the sets, while 3, which is present in set A, is not present in set B. And we had seen that the subset should have all the elements. The A and B here, since A has 1 and 3 but B has only 1, 5 and 9, it does not have B. So to be a superset of A, or conversely for A to be a subset of B, all the elements of A should also be present in B, but that is not the case here. 3 is one element which is not present in B, and that is why A is not a subset of B. So now I am leaving you with the part 3 and part 4 of this particular question, and question number 4 also, example 10 also, so that you can have a understanding of your own and you can assess how much you have understood this particular content on sets, subsets and supersets. Kindly pause the video wherever you are finding it difficult to follow me, and kindly solve the questions that I have left for you, and we'll be continuing the discussion in our next session. Thank you very much.